Assume that the total cholesterol levels for adults are normally distributed with a mean cholesterol level of 51.9 milligrams per deciliter and a standard deviation of 14.3 milligrams per deciliter. Find the probability that an individual will have a cholesterol level greater than 58 milligrams per deciliter. Alright, there are a couple of things that we need to look at in this particular problem so that we can understand exactly how to solve it. First off, once we've read through the problem, assume that the total cholesterol levels for adults are normally distributed, and that's going to be a key component because in order to do this, we're going to need the standard normal distribution table. And then we're given the fact that there's a mean cholesterol level of 51.9 milligrams per deciliters, and the units aren't as important in this particular problem because we're looking for a probability here, but we'll get to that in a moment. But you do need to kind of have an understanding of what units mean in general. So we're going to write this down as mu is equal to 51.9. And then we're told that we have a standard deviation of 14.3 milligrams per deciliter. So we'll write down sigma is equal to 14.3. Now this last sentence is exactly what we're looking for in the problem. And it states, find the probability. That means that it's going to be a probability function that an individual will have a cholesterol level greater than 58 milligrams per deciliter. And I can write that in the following way as some x is greater than the target number of 58. So that's our probability statement. Now, in order to do this, I'm going to have to use, as I said, the standard normal distribution table. And in order to do that, I need to look for a z-score. So that's where we're going next. We will find a z-score for x is equal to 58. And remember that z is calculated using the following: x minus mu over standard deviation. So we'll go ahead and say, okay, x is 58. We're going to subtract from that our mean, which is 51.9, and then we're going to divide that total by the standard deviation, which is 14.3. And once we calculate that, we will get the fact that z is approximately equal to 0.42657, and it continues on, but we're only really concerned with 2 to 3 decimal places for this. So we're going to round and get z is approximately equal to 0.43. This is what we're going to look for in the table. We will find this z in the table. So now we have to look at the table, and I'm only going to import part of the table so that we can look at it. So now that I've brought in this portion of the standard normal table, what we're going to do is we're going to go ahead and define what we need to find. So remember that this 0.43 is the same thing as having 0.4 and then 0.03, and we add them together to get the 0.43. The reason that I bring that up is because if you'll notice the columns here, this first one, it has z, and it goes off in a horizontal direction and also in a vertical direction. This 0.4 part that I'm putting in a rectangle right here is going to be in this first column and will be right here. And then we're going to look for the 0.03, which I am now circling or putting in a rectangle. And that's going to be across the top row, and we'll find 0.03 right here. And then we're going to find where these two rows, row and column, intersect, which is going to be right here. So that means that when z is equal to 0.43, the area under the curve is equivalent to 0.6664. So we'll go back to our original statement of p is, or I should say p of x is greater than 58. Well, in order to do that, I'm going to need to go ahead and find the probability that z is greater than 0.43. And that means that I'm looking at the probability of z being less than or equal to 0.43, and that's going to be subtracted from 1. Because this value over here in the table that I'm now putting a line around is the probability under the curve less than 0.43. And if I were to draw that using the normal distribution curve, and it doesn't have to be perfect, I know that z equals 0 is the same thing as the mean of the distribution, and it splits the curve in half, and everything to the left would be 0.5 of the area and everything to the right would be 0.5. But this 0.43 is going to be somewhere right about here. But since we're looking at greater than, we want to go ahead and look at everything that's above that. But the table will always give us what is below that z-score. Hence the reason that we're going to have to subtract from 1, because the total area under the normal distribution curve is equal to 1. So now let's go ahead and continue this. This is going to be equal to 1 minus, remember the area is 0.6664. And once we subtract that, we get the following, 0.3336, which means, and therefore, the answer for this, the probability that an individual will have a cholesterol level greater than 58 milligrams per deciliter is approximately 33.36%.